Dear students, welcome to another session of programming using C language. Myself, Harsh Bansal, Assistant Professor from Computer Science and Engineering Department, Chandigarh University, Garhwa. In this session, you'll learn on how to format input and output. Takeaways from this session are formatting functions printf and scanf. Printf function, which is used to convert data stored in the program into a text stream for output. Scanf function, which is used to convert text stream coming from the input to data values and store them in program variables.
We'll also learn about the prototype of the control string used in the printf function, which uses elements namely flag, width, precision, length, and type specifier. So let's get started. Now, as you know, that printf function here, print and f stands for formatting, right? So printf function is used for printing the output as well as formatting the output, right? So it is used to display information required by the user. It also prints the value of the variables. It takes the data, converts them into the text string for output using formatting functions as specified in the control string. Now, the control string may contain text string that has to be displayed on the screen and control characters such as \n, \t. The parameters which you see here in the control string, right? Some of them are optional and some of them are mandatory. The parameters which are specified here in this square brackets are optional parameters, right? Rest of them are must. For example, here percentage and specifier are must to be specified ones, and the ones in the square bracket such as flags, width, precision, and length, these are the optional ones. We'll learn about these more in depth one by one. Now, talking about flags, so they are basically used for justification, right? Now, by default, whenever you print any value, that will be printed towards the right. So by default, the output is right justified. In case you want the output to be left justified, we'll use the flag minus. Next, we have plus. Now, plus is used to display the numeric sign, whether it's positive or negative. Though negative values will have their sign, but if you want sign to be displayed with a positive value, in that case, we'll use the flag plus. Apart from that, we have another flag, which is hash. Now, this is used to convert the decimal into octal or hexadecimal format, right? So if you want to, convert the value, let's suppose, we want to display hexadecimal memory addresses. Now, in that case, a hash will be useful. Next, we have 0. Now, this is used to pad the space with zeros. As we know that by default, the output is right justified. So if we have spaces in front of the output and we want the spaces to be replaced with zeros, so we'll use the flag 0 within the control string. Talking about width and precision. Now, width tells the minimum number of characters to be printed by the printf statement, whereas precision tells the maximum number of characters to be printed. For example, if we talk about float, right, and it has a value of, let's suppose, 3.14 and so on, and I want that, what should be the maximum number of digits to be printed after the decimal. Now, that will be specified with the help of precision, right? Precision tells accuracy, how accurate we want the results to be, right? If we extend the number of decimal places, it will be more accurate or it will be more precise. If we reduce, it will be less accurate or it will be less precise, right? So precision tells that how many characters, in case of float, how many characters to be printed after the decimal, right? And width will specify that what will be the maximum, or sorry, minimum number of characters there in the output. Then we have length field in the printf statement. Like you know that we use modifiers short and long along with the data types. Now, if you are using shorthand, let's suppose, then in that case, in order to mention that you'll be printing value which is of short in type, you'll use the length field h. In case you are using long int, in that case, you'll be specifying small l along with in the control string, right? And in case you are making use of long double, in that case, we'll be using capital L in order to specify uh, the use of the modifier along with the data type. Next, we have specifiers. So you know that C is used for characters, D is used for decimal values, F is used for floating point numbers, right? Similarly, we use O for octal, and we use U for unsigned decimal values, X for hexadecimal values, and S is used for string of characters. Now let's have the demonstration of what we have discussed in this particular session. Let's take an example. Let's suppose we have int of x that has a value of 1, 2, 3, 4, 5. Now, if we simply print this particular statement, we'll use %d, right? Because you know percentage is must and specifier is must, because we are using integer. So the specifier for integer is d, right? Now we'll pass the variable to the control string and we will get our value on the output console. Let's check out the output. So the build has succeeded. And what we have 1, 2, 3, 4, 5. Now we will make use of some flags in order to understand that how do they work. Now we will make use of the width over here. Let's specify the width of the output to be 10. Now, if we rerun this particular statement, what we will get is, we'll see that by default, the output is right justified, right? And we have few spaces onto the left, right? Now, in order to check how many spaces we have, we can replace the space with zeros. In order to do that, you will use 0, which is our flag. So let's run this program now. And what we will see is we have 0 padded at the left of the numerical value. So we have 1, right? So we have total number of 5 zeros, and then we have, you know, our numerical value, which is 1, 2, 3, 4, 5, right? So we are using a total width of 10 in the output. Next, what we can do is, like, as I said, by default, the output is right justified. If you want the output to be left justified, what you'll do is you'll make use of minus, right? And 1, 2, 3, 4, 5 in that case will be printed onto the left. Let's run this up. Now, what you see is that we have 1, 2, 3, 4, 5, the numerical value stored in the variable, printed on the left. There are no spaces now. Now, what if I use 0? Will I get zeros onto the left? The answer is definitely no, because I will manipulate the value which we have stored within a variable, right? Let's run this up. You could see that flag 0 is ignored when flag minus is present. So it has no significance. Even if you run it, right? That won't make any change to the output, and we'll still get the same. Next, what we know of is that we can convert this value into hexadecimal or octal. In order to do that, we know that we use hash flag, right, in the control string. Now, if you want to convert into octal, right, so you will use O. So you can write the octal value for decimal value percentage %d is percentage hash O, and here we will pass the variable. So in this case, this x will be passed to percentage %d, and this x will be passed for converting into the octal value. Let's run this program. So the octal value of 1, 2, 3, 4, 5 is, now here it specifies O, that it's an octal value, and this is the octal value for 1, 2, 3, 4, 5. Now, if you want to convert it into hexadecimal, right? So you'll write the hexadecimal value for the decimal value percentage %d is, let's run. So this is the hexadecimal value. Now you could see it uses X over here because it specifies that it's a hexadecimal value. Now, next, because it's a positive value, when you just write percentage %d, you don't get the positive sign along, right? Because by default, it will be considered to be as positive, right? Let's run this. So what you get over here is you get 1, 2, 3, 4, 5, but there is no sign because by default it will be considered as positive. But what if I want to print the positive sign? In that case, you'll use flag plus, right? And when you do that, you'll see that you will eventually get plus along with the value. So it'll start designating the value with plus in case if it is positive, right? In case if we have a negative value and you are making use of plus, definitely that won't override, right? The value would remain negative, and so we'll get a negative value, which is minus of 1, 2, 3, 4, 5, right? And similarly, we can have the demonstration with the help of a float type value. Let's say float of x is equal to 22/7. Now here is a very, very interesting thing. Now you might be expecting that we'll get a accurate value in x, so but it won't happen. I'll describe why it won't. So we would be expecting a value of like 3.14, and so whatever the value of pi is, but we won't get that. Why we won't get that, we'll see in a while. Let's see. So percentage f, and let's try to print the value of x, right? Let's run this program. So what do we get? We get 3.000000. Now this shows that float has a precision up to 6, 1. Another thing, something is wrong. We not getting the right solution. Why is it so? Because here you are dividing integer by integer. When you are dividing integer by integer, this will result in integer, right? So you got 3 first, and then it got converted into float. And that is why you are getting 3.00. In case you want a float type value, either you make one of these as float, right? Either 22.0, 7.0, or both as float, or either you do typecasting. All right. So one way to do it is this. So now you get the right answer, right? So this is the value of pi up to 6 precision. In case you don't want to do this, what you can do is you can make use of typecasting, right? So you are casting the value here, And again, you'll get the same value which we got before, right? So you can do any of the following. Now let's see that how do we make use of float, and how do we make use of control string with the float data type. Now, if I specify, let's suppose the width is 10 and the precision is 2. That means the total width of the output will be 10, and after decimal you'll get maximum of 2 digits. So let's check the output. Let's see what do we get over here. So as you see that by default the output is right justified. So we have spaces over here, right? And it is using a total width of 10, right, including the decimal, right? And if you want to see that how many spaces we have, you can pad it with 0, right? So this is how you can check out. Now here is a very, very important concept, everyone. Now whatever value we have onto the left of the decimal, right, that will never be truncated. But whatever value we have after the decimal will be truncated as of the precision. Now, to make you understand this, let's suppose if I say, let's take this example. So integer will clear this pretty much. So let's suppose we have 1, 2, 3, 4, 5. And in the printf statement, you mention percentage %d of x. And when you're mentioning the format specifier, here if I mention the total width as 2, now will I get only 2 digits of the value assigned to x? No, because this specifies the minimum number of characters, not the maximum number of characters. Now if your numerical value has more characters than what you have specified, then it will override, right? And what you will get is you'll get the actual result. So just check over here, right? So you will get 1, 2, 3, 4, 5. It won't limit, right? So the width does not limit the value. But yes, if we talk about precision, right, definitely the precision could be controlled, right? Whether you want up to 2 digits, whether you want up to 4 digits, whether you want up to 3 digits, right? So you can check this out. And this is what we will get as a result, right? Next, we did learn about the length field as well. Now, as you know that when you specify an integer type variable, now you can make it shortened, right? And you can make it long end as well, right? Now, any of these two could be used to modify. And in case you are printing value which is of shortened type, right? So you will use h along with in the format specifier, right? If you are using if you are printing a long end value, so you'll specify L. So how to do it? Let's just check it out. So printf percentage d, sorry, the value of short int variable is, you'll write percentage, and here you'll use h and d, right? And we'll pass the variable x, right? Similarly, if we are looking for long int, the value of long int variable is percentage ld, right? This is how we will specify. So you will pass y to it, right? So let's run this program. And this is the output we have, right? So we specify the size, right? With the so we specify the length with the help of the specifiers like H and L, right? In case it is long double, right? So in case you have specified long double, right? Then let's suppose you typecast it to double, and you write 22 by 7. Let's check out the value. So we are storing it in variable Z, right? Now in this case, what he'll do is the value of long double variable is, so here you'll specify capital F, right? And you'll specify F, right? And here you'll replace it with Z. Let's check out the output. So this is the output we have in case of a long double, right? So I hope it clears you out with how to use format specifiers, right? How format specifiers help us in formatting the output. Now let's get back to our presentation and let's revise what we have learned in this particular session. So what we have learned is that flags are specifically used for output justification. Width is used to specify minimum number of positions in the output. If you have more number of digits in the output, then that will override the width, right? So that's why it's minimum number of positions. Next, we have precision, which specifies the maximum number of characters or digits to print. Like, for example, in case of float, it will specify the number of decimal places to be printed. Next, we have length modifier. We have H for short, and we have small l for long, and we have capital L for long, right? And then we had discussed some type specifiers. For example, we use C for character, F for float, D for integer, and we use S for string, and we use O for octal, X for hexadecimal, right? So these are the various type specifiers we have. Now, out of these, type specifiers merged as of the data type. Flag, width, precision, and length are the optional ones, right? So format specifier help control the manner in which input or output of the values has to be done. Now, I'll leave you with some of the questions to review or to check your understanding towards the session. Let's have a look at the questions, and we'll discuss the answers at the end of the session. So what will be the output of the following statement? You have width as 2. We are printing an integer type value. And the value passed is 1, 2, 3, 4, 5. And here are the options. Talking about the next question, we have what will be the output of the following statement? We have 8 as the width, 2 as the precision. We want to print a float type value, and the value passed is 123.1234567, right? So what will be the output in this particular case? Make a note of your output. Next question we have is this a valid printf statement? Now this is a very interesting one. I want you to try this out on the compiler and come up with an answer. Next, what will be the output of the following statement? Percentage 03D, and we are passing 12 as the integer value. So the answers to the question now. The very first answer to the question is the correct answer is 1, 2, 3, 4, 5. Why? Let's discuss. We have because whatever length of the numerical value is, right? If the width is more or the number of digits in the value are more, it will override the width, right? Because width specifies a minimum number of characters or digits to be printed in this case, right? Next, moving on to the next question. Here, will have a total width of 8, right? And as the output is right justified, so we'll have spaces onto the left, right? And we'll have 2 spaces onto the left, right? Making a total width of 8. So right, option A is the right answer. Here, talking about this particular question, now the width and the precision can be specified like this. And here 3 will be the width and 2 will be the precision, right? So 3.14 will be passed as a float type value, and definitely yes, it's a valid printf statement. This will give you 3.14 as the output. Next, we have 0 3D. As you know, 0 is used for padding, right? So a total of 3 will be the width of the output. And as we have only 2 digits there in the numerical value, so you'll have 1 0 onto the left of the value while it's getting printed. So definitely option A is the correct answer. So that's it from my side. We'll see you in the next session. Thank you.